Hello dear students, welcome back to your math classes. How are you all? I hope you all are doing well and I hope so you have completed your previous chapter revision as well. So students, today we are going to learn about cubes and cube roots, which is chapter number 4. We already learned about the square and square roots. So it means that we have to learn something similar, which is similar to square and square roots. So in this chapter, you also face some methods which is common in square and square root. Two methods to find out the square root we have. I hope so you have the name on your tongue, which is prime factorization, and the second long division method. So both the things we are doing here as well. So first of all, cubes. The cube of a number is that number raised to the power 3. Cube of a number is a cube. For example, 2 raised to the power 3, it means 2 multiplied by 2 multiplied by 2. It means in square and square roots, what we have done, we multiply a particular number by 2 times. Okay, but in cube and cube roots, we have to multiply that particular number by thrice, yani 3 times. So we have to raise our power like this. You can say 2 cube, or you can also say 2 raised to the power cube. Yeah, 2 raised to the power 3. Note that unlike square of a number, cube of a number can be negative. It means that if we have a negative number, for example, minus 2 raised to the power 3 or 2 minus 2 cube, it means the answer will be in negative only, because minus, minus and minus is equal to minus only. Okay. Next we have cubes of natural numbers. Perfect cubes as similar to perfect square. Okay. A natural number is said to be perfect cube if it is the cube of some natural number. Natural number n is perfect cube if n is equal to m cube for some natural number m. 8 is a perfect cube as 8 2 cube. 125 is a perfect cube as 5 cube. 1000 is a perfect cube as 10 cube, etc. Is 21 a perfect cube? No, because there does not exist a natural number whose cube is 21. The prime factorization of number can be used to check whether a given number is a perfect cube or not. If the prime factors of the numbers can be grouped in triplets. In square and square roots, we make a pair, right? But in this, we group in triplets. We have to make a group of 3 numbers. Next, in such a way that all 3 factors in each triplet are equal and none of the factor is left over. Then the number is perfect cube, otherwise not. It means according to prime factorization method, if we are able to make a triplet, okay, then the number it is in itself a cube, okay, otherwise it is not a cube. So I hope so student this is clear to you. Next we have which of the following numbers are perfect cube. So how can we check this? So first of all, we have a number 216. We take prime factors of it and we get 2, 2, 2, 3, 3, 3. It means we have triplet of 2 and triplet of 3. And this is the condition now for the perfect cube. So 216 is fulfill the condition for 2 become a perfect cube. Making triplets of equal factors, we get this. Since no factor is left over in grouping of factors as triplet, therefore 216 is a perfect cube. Next, writing prime factorization of 729 and making triplets of equal prime factors, we get triplets of 3. So it means it is also a perfect cube. Next we have 2376, but in this what we look, okay, we have okay one triplet, okay, second triplet, but we have a leftover number which is 11, and according to perfect cube rules and conditions, what we have to concentrate that there is no leftover numbers. So it means 2376 is not a perfect cube just because they are left over 11. Now, what is the smallest number by which 200 must be multiplied so the product is a perfect cube? So again, the same question which we are doing in a previous chapter, square and square roots, where we have to find out the smallest number which we have to add, which we have to subtract, multiply, division. So it means what we have to do, first we have to take the prime factorization of 200, and with that what we conclude, okay, we have a triplet of 2 but we have a pair of 5. It means 5 in this grouping, prime factor 5 occurring twice is left out. To complete this as a triplet so that we get a perfect cube, 200 is to be multiplied with 5 only. I hope student this is clear to you, and this is very easy. You can relate it with your previous chapter also. Now, what is the smallest number by which 686 must be divided so that the quotient is a perfect cube? So again, the same process, the same method you have to apply here. You get the prime factorization of 686, and what you find? Okay, here we have a leftover number which is 2. It means we have to divide this number with 2 to get a perfect cube. Find the smallest perfect cube which is divisible by 6 and 9. Again the same question. So what we have to do? First we take the LCM of 6 and 9. So we get 36. And while we have 36, so what we see? We have only pair. And in perfect cube, we need triplet of numbers. So 1, 2 is extra here. We have to put here. And 1 extra 3 we have to put here. It means 36 multiplied by 6, because extra 2 and extra 3. 2 multiplied by 3 is 6. So 36 multiplied by 6, 216 is the smallest perfect cube which is divisible by 6 and 9. So I hope so students this is clear to you. Okay. Now is 8000 a perfect cube? If yes, then what is the number whose cube is 8000? So first of all you have to find this. We have a triplet of 2. We have a triplet again of 2. Then 5. So 2, 2 and 5. So 2 multiplied by 2 is 4. 4 multiplied by 5 is 20. It means 8000 is the perfect cube of 20. Now properties of cubes of natural number. So cubes of the numbers ending 1, 4, 5, 6 and 9 are the numbers ending in the same digit 1, 4, 5, 6 and 9 respectively. The cubes of numbers ending in 2 and 8 and the cubes of number ending. Okay. So what we see here, the cubes of the numbers ending with this number and the numbers ending with the same digit with this number. The cubes of numbers ending in 2 and in 8, the cube numbers ending. So in 8 and in 2, similarly the cubes of numbers ending 3 and in 7 and the cubes of numbers ending 7 and 3. If a number ends in a 0, then its cube ends in 3 zeros. So in square and square root, we have some properties where we have to focus on that the last number should be 2, 4, 6, 8. So it means it is a perfect cube or not. It is not a perfect cube. And if we have zeros, so we have even number zeros. Okay, we have 4 zeros, 6 zeros, 8 zeros like this. So same properties we have here for the cube and cube root. So I hope so this is clear to you. Next, this property is illustrated by the following table which gives the cubes of perfect first 20 natural numbers. The cube of an even number, even natural number is even. So look at here. 4 cube ends with 6. 6 cube ends with 6. 8 cube ends with 2. So the cube, okay. So you have to look at here. 1 cube, 1. 2 cube, 8. 3 cube, 7. 4 cube, 4. 5 cube, 5. And these are the numbers we are looking at here. 1, 4, 5, 6, 9. 1, 4, 5, 6, 9. Okay. And we have zeros with odd numbers as well. Okay. Even natural number, cube root is even numbers. The cube of an odd natural number is odd, and the sum of the cubes of first and natural numbers is equal to the square of their sum. It means if I am taking 1 cube, it means 1 plus 1 square. Then we have 8, 1 cube plus 2 cubes, so 9. It means 1 plus 8 is equal to 9. Then 1 cube, 2 cube, 3 cube, it means 1 plus 8 plus 27 is equal to 36. So in that way we are doing solve it. Now cubes of negative integers. So I already told you if we have negative integers, it means the end product is also in negative. Okay. Thus cube of a negative integers is negative and is opposite negative of the cube opposite negative of the number or for a natural number. A negative integer is said to be a perfect cube if it is the cube of some negative integer. Okay. For example, minus 8 is a perfect cube as minus 8 is equal to minus 2 cube. Minus 25 is a perfect cube as minus 25 is minus 5 cube. For example, to check if minus 1728 is a perfect cube or not, we check the same for 1728 resolving into prime factors. So we have a triplet of 2, 2 and 3, it means it is a perfect cube. This is the method to find out the is this a cube we having, it is a perfect cube or not. So cubes of rational numbers, the same process we have to apply here. 2 by 3 cube means 2 cube and 3 cube, which is 8 by 27. Now 1 by 6 cube, which means 1 by 6, 1 by 6 and 1 by 6. 1's cube is 1 and 6 cube is 216. That's the same process you have to apply here. Don't be confused what we have to do when we have rational numbers. The same process you have to fulfill here. Thus, if p by q is a rational number, then p by q cube is also a p cube to the q cube. You can find cubes of decimal numbers by converting decimal numbers into rational numbers. So first we have decimal numbers. First we have to convert this number into rational numbers, which is point after point we have 2 digits. So 2 zeros are there. 2 by 100 cube, which means 2 cube and 100 cube. So this is our answer, 0.00008. Okay, or directly as 0.02 cube means 3 times you have to put 6 numbers after the digit. So 2, 2 and 2. So it means 1, 2, 3, 4, 5, 6. 6 digits we have after the decimal point. Find the cubes of the following numbers. So we have to find out the cube. So 8 cube is 8 multiplied by 8 multiplied by 8. So check it out. 8 8 is 64 and 64 8 are. Wait for a second. You can go through this table as well. 8 cube is 512 and 11 cube is 1331. So 5 1 2, it is an answer 5 1 2 and 1331. Initially you can go through your table and learn some of them cube roots to get your calculation easy and faster. Otherwise you can do your calculation as well. What you have to do, you have to multiply that particular number 3 times with itself only. Okay, now which of the following are perfect cubes? So first of all we check for this one. So let's take it out, the prime factorization of 64. So 2 3 2 2 1 6 2 8 2 4 2 2 and 2 1. Triplet of 1 and triplet of 2. The 2 triplet we have of 2, it means 2 multiplied by 2, it is a perfect cube of 4. Okay, in same way you have to check out for the others as well. And 1331 we already see here, it is a perfect cube of 11. Okay, for each of the following numbers, find the smallest number by which the given number should be multiplied so that the product is a perfect cube. It means what we have to do, 108 divided by 2, 5 and 4, 2, 2, 7, 3, 9, 3, 3, 3, 1. It means we only have a triplet of 3 and we have a pair of 2, which means we have to multiply this number with 2 to get a perfect cube. Okay, so in that way you can find out, and after the you will get 2 8s are 16, 1 2 0 1 and 2 8. This is your perfect cube. Okay, for each of the following numbers, find the smallest number by which the given number should be divided so that the quotient is a perfect cube. So students, I already told you, whenever we have asked for the smallest number in respective of the addition, in respective of the subtraction, division and multiplication, what you have to do, take the prime factorization, which number is without a triplet. For example, here we have number which is not in a triplet, which is 2. So we have to multiply that number with 2. It means the same process we have to apply for question number 4, for question number 5 and what, okay, for question number 4 and question number 5, you have to apply the same process. What is the unit digit of the cube? Your unit digit is 3. Now we have to take the cube root of 3. 3 multiplied by 3 multiplied by 3. 3 3s are 9 and 9 3s are 27. So the unit digit will be 7 only. Next we have 4 and we already find out the square cube root of the 4, which is 64. it means the unit digit will be 4 only. Okay, so what you have to do, first you have to find the last digit, then the last digit you have to multiply 3 times, 1 2 3. Now check, solve this, find the product of it. 2 2s are 4, 4 2s are 8. So what you will be find, 8 is the unit digit for 52 as cube root. Next we have, without calculating, find which of the following numbers have cubes which are even. So what you have to do, you have to check the last number. If last number is an even number, it means the example is cubes are in even, and if the last digit is odd, so it means the your cube root will be in odd. So this is an odd number, so this odd. 4 is an even number, so cube is also even. 0 only 1, so we cannot say anything for this. 8 is an even number, which means it is a even cube. Next, the same question we have to find out for the odd natural number. 3 is an odd number, which means it is a odd. 2 is an even number. 7 is an odd number, which means this is also odd. So according to last number, last digit, one's place, you can find out your cubes having even or odd. Which of the following numbers are cubes of negative integers? So minus 125 cube, it is a cube root of minus, because when we multiply minus 5 and minus 5, so minus minus will get plus. Again we have minus, which means minus. So according to that, you can find your answer. Okay, which of the following numbers are cubes of rational numbers? So easily you can check which numbers are in the rational numbers. Now 8 is a cube root of 2 and 125 is a cube root of 5. So this is that way you can find easily. Okay, so students, we have completed this exercise. Now we have the next concept, which is cubes root. Cube root means, okay, now we have to find out the cube, and now we have a cube root and we have to calculate what is the number of that cube root, which means in the previous chapter you have learned that finding square root is the inverse operation of finding square. Similarly, finding cube root is the inverse operation of finding cube. Cube root, the cube root of a number a is a number b if b cube is equal to a. The cube root of a number a is denoted by this sign. In previous chapter, we just symbolized this sign. We are not mentioning any number, but in this, we have to mention a number of 3 over there to identify, okay, fine, we are calculating the cube root of particular number. So, for example, 8 cube is, so 8, which number having 8 cube? That is 2. 125 is a cube root of 5. So, now 729 is a cube root of 9. Minus 64 is a cube root of 4. So, in that way you have to find. For any positive integer n, minus n cube is equal to minus cube, which is, you have to denote it the same way. Like in this, we have a minus n till here when we put it down in the cube root symbol as well. So, cube root of a negative perfect cube is negative of the cube root of its opposite. For any rational number a by b, we have the cube root a cube b cube, which means the whole sign of cube with a cube and b cube. Thus, if you know how to find the cube root of a natural number, then you can find a cube root or roots of negative number and a rational number as well, which is common. So now, computation of cube root of a natural number. To find cube root of a natural number n, you have to look for a natural number m such that m cube is equal to n. In this section, you shall learn various methods of finding cube roots of natural numbers, which are perfect cubes. Okay, so cube roots to a pattern. So first of all, we have 1 cube, which is 1. 2 cube minus 1 cube is 8 minus 1, which is 7. 3 cube minus 2 cubes, 27 minus 8, which is 19. 4 cube minus 3 cube is equal to 64 minus 27 is equal to 37. So in this, what we find out, these are the numbers we have, which we have to get. Okay, these statements lead us to the following patterns, which is 1 cube is 1, then 2 cube is 1 plus 7. 4 cube is 19 plus 8. 1 plus 7 plus 9. 4 cube is 1 plus 7 plus 19 plus 37. So these are the terms we have, which we have to add on. For first one, only 1. The second one, 1 plus 7. The third one, 1 plus 7 plus 19. For the fourth one, 1 plus 7 plus 19 plus 37. So you have to continue like that way till 169 and you will get your cube roots. Okay. Now, can you write 9 cube in this form? Observe the difference between successive odd numbers on the right hand side. So we have to write for the 9 cube, which means 1 multiplied by 6, 1, 7, 19, 37, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers. Okay. Now 1 multiplied by 6, 2 multiplied by 6, 1, 7, 19, 37, 61, 91, 127, 169, and the last process we have 169 plus 8 multiplied by 6. Okay. So in that way we can represent this, which is 217. After solving this, to find cube root of a perfect cube, subtract from it successively 1, 7, 19, 37, 61, 91 and so on. The number of subtractions which have to perform to arrive at 0 gives the cube root of the given number. So these are the numbers which we have to continuously subtract, which number we have to find, okay, this is a perfect cube or not. So in that way we have to solve the whole process. Now for example, to find cube root of 216 means 216 minus 1, then your answer is 215 minus 7, 208 minus 19, 189, then 189 minus 37, 152, then 150 minus 61, 91, and then 91 minus 91 is 0. Students, what you have to do now, you have to see this pattern, and while you have to calculate according to this method, so continuously you have to subtract from the given number 7, the end answer which you have, then minus 19, and you have to continue this process till you get 0. Now, since subtraction in 6 steps gives 0, therefore the cube root of 216 is 6. This method of finding cube roots is convenient for small numbers, but for large numbers, it will be lengthy and cumbersome. Now, cube root by using units digit of the number. This method of finding cube roots can be used to find cube roots of perfect cubes having at most 6 digits. The smallest 7-digit number is this. A perfect cube and its cube root is 100, which is the smallest 3-digit number. Therefore, the cube roots of a perfect cube having at most 6 digits has the at 2 digits. Moreover, looking at the units digit of the numbers, you can write the units digit of its cube root. Recall property of cubes, natural numbers. Based on the above explanation, the procedure for finding the cube roots is given below. So, how can you calculate this? Determine the unit digit of the cube root from the unit digit of the given number. This takes care of the digits at unit, tens and hundreds placed in the cube. So, find the cube root of 343. So, we are going to learn whole this step with the help of an example, which is this. So, since the unit digit in the given number is 3, unit digit is 3, one's place is 3. The first step is fulfill here. The unit digit in its cube root is 7. So, now the cube root is 7. How can you calculate is 3. Now, the second, if the given number has at most 3 digits, then the digit obtained in step 1 is the required cube root. It not then consider the number obtained after deleting the last 3-digit unit, tens and hundred of the given number. Determine the largest single digit number whose cube root is less than or equal to this remaining number. This number gives the digit at tens place in the cube root. Write the required cube root by placing the digit obtained in step 1 and step 3 at unit and tens place respectively. The example given below illustrates this method. So, what we do? First, we determine the unit place, which is 3. The unit digit in cube root is 7. Cubes with at most 3 digits have a single digit cube root. 343 being a 3-digit number has a single digit cube root. The 3 cube root is 27, right? 3 multiplied by 3 multiplied by 3. And 3 3 is a 9, 9 3 is a 27. So, the unit digit will be 7. Okay. Find the cube root of 1,57,464. Since the unit digit in the given number is 4. Okay. The unit digit in the cube root is 4. How can you calculate? 4 multiplied by 4 multiplied by 4 is 64. So, the unit digit is 4. After deleting the unit, tens and hundreds, the digit number left is 157. So, what you have to do? You have to delete this 1, 4 and this. So, you will get 157. Now, the largest single digit number whose cube is less than or equal to 157 is 5. 4 cube is 64 and 5 cube is 125 and 6 cube is, so you have to go through the table one more time. So it means this is your number according to, therefore 5 is the digit at tens place. Okay, so thus this is a cube root of 54, the unit place and the number 54. Cube root through the prime factorization. To find cube root of a perfect cube through the prime factorization, do as follows. We already told you how you have to solve it. This is your number 9261. Get the factors of this with the help of prime factorization. What you find, we have a triplet of 3 and a triplet of 7. It means 3 multiplied by 7. It is a cube root of 21. This is the simpler one. Okay. Next, find the cube root of minus 13,824. So again, you have to fulfill the same process. 1 triplet, second triplet, 4, 3 and 4. So 2 2s are 4, 4 2s are 8 and add 3s are 24. So it means it is a cube root of 24. Now we exercise 4.2. So I hope students, the examples are clear to you. If you have any doubt in examples now, first clear your example, then try to solve your exercise. Okay, before that, don't try to it. Now find the cube roots of the following numbers by successive subtraction of number this. So how you can calculate? So in this we have 125. So first we take 125 minus 104 minus 7. 4, 120 minus 1, 17 minus 19, 17, 98 minus 37 is equal to 61 minus 61 is 0. So we have 1, 2, 3, 4, 5. It means it is a cube root of 5. Okay. The same way you have to do rest of the questions. Find the cube roots of the following perfect cubes by using their unit digit. So this is the unit digit of 4. So 4 multiplied by 4 multiplied by 4 is 64. So this is your 4. Now what you have to do, you have to see the number which is, now you have the number 227. So 27. So 34 should be the number. Let's see. What you have to do, check out the numbers, because 27, you have to cancel out the numbers. So it means it lie between 34 something. Now the next number is find the cube roots of the following numbers by prime factorization. So we take first question 64. And we already know 64 is the cube root of 4. So you can take prime factor. So what you see, you have two group of triplets of 2. So it means it is a cube root of 4. Now find the cube root of each of the following numbers. So this is an example. Sorry, this is your question, which is 512. 2 multiplied. So 2, 5, 6, 2, 1, 2, 8, 2, 6, 4, 2, 3, 2, 2, 1, 6, 2, 8, 2, 4, 2, 2, 2, 1. 1, 2, 3. 2 multiplied by 2 multiplied by 2. 2 2s are 4, 4 2s are 8. So it is a cube root of 8. So in that way you have to solve these rest of the questions. Okay. With that you have completed your exercise 4.2 as well. Now you have some points which you have to remember. The point number 1 is the cube root, the cube of a natural, the cube of a number is that number raised to the power 3. For a number a is a cube, means a multiplied by a multiplied by a. A natural number n is said to be perfect cube if n is equal to m cube if for some natural number m. Cubes of numbers ending in digit, these numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and end in digits 0, 1, 8, 7, 4, 5, 6, 3, 2 and 9 respectively. The cube of a even natural number is even. Odd or natural number is odd. For any natural number n, 1 cube, 2 cube, 3 cube is this. If n is a positive integer, then you minus n cube is minus n cube. Next positive, so we have positive now. If a by b is a rational number, then a cube and b cube. The cube root of a number a is a number b if b cube is A. So this is the sign of fruit. So I already told you all these concepts in your chapter, but you want all information in a compiled form, so you can take this page as the informational page and you can conclude your concept in this as well. So students, for today that's it. I hope this chapter is clear to you. Make sure you have tried enough question and practice enough question to clarify your doubts and make yourself strong in this chapter. So now I'll meet you in your next class with a new chapter. Till that, bye bye. Have a good day.